Okay, so kinematics equations are the equations that we deal with when we are working with kinematics. Remember what we have said about kinematics, that is that part of physics or part of mechanics that deals with the question, how is the object moving? Meaning that it's asking what is the initial velocity, what is final velocity, what is time, what is acceleration, what is displacement of the object moving. We do not care too much what is the mass of the object, what is the nature of the object, what is the relationship of the object with the surface that the object is moving at. So we just worry about those quantities. Therefore, if you open your formula sheet, then you will see that there are some equations on the page where the equations are, and those are something like this. There are 6 equations. So the first one is acceleration is equal to the change of velocity over change of time, or as we have discussed in the previous lesson, is the rate of change of the velocity. So it's v final minus v initial over time. Then next one, I think that there is an okay, displacement is equal, let's do this, is v initial t plus 1 over 2 a t squared. Next one is displacement is a v final t minus 1 over 2 a t squared. I didn't videotape this. So then we have, as I said, the average velocity. That is a formula that you have seen even in Science 10 and pretty much every time that since you started working with physics. And then displacement is v final plus v initial over 2 times time. And then the last one is v final squared is equal to v initial squared plus 2ad. Those are the 6 kinematics equations. So if you can square those 6 up into your formula sheet, then this is where we will be focusing on for the kinematics part. The other 2 formulas we will deal when we talk about the uniform circular motion later on the course. For now, those are the 6 formulas that we will deal with. And the way that we approach them, any question that is asking us to use kinematics equation is we sort what is given, what they are asking for, and then we take a look at one of those formulas and see what is the formula that relates all given and what they're asking for. Okay, here, final answer. And correct sig digs. Now, the sig digs, correct sig digs is, take a look at what is given. The lowest sig digs is what the answer has to be. Okay, so let's take a look at this. An airplane accelerates down a runway at 3.2 meters per second square for 32.8 seconds until it finally lifts off the ground. Determine the distance traveled before takeoff. So now I will leave you 2 minutes, 1 minute to sort out what is given, what they are asking, and then go from there. So what is given here? What is that 3.2 meters per second squared? On the chat, guys. Acceleration, good. So acceleration is 3.2 3.20 meters per second squared. And 32.8 seconds, as you see it here from the units, you can say that it is what time? Time is 32.8 seconds. And what they are asking you is the distance. Okay, distance. What else can we draw from the problem? Excellent, great answer. Initial velocity is equal to 0. So from the question is reading and understanding it, okay? We have expression at Father Lacombe saying that read the question. So this means that some information there is hidden between the words. Okay, so now in your formula sheet, what is the formula that we will use? And I will bring this first page here and then say, label them 1, 2, 3, 4. So this is equation 1, equation 2, equation 3, equation 4, equation 5, or equation 6. Just for simplicity, it is equation 2. It is 2 because we are looking for displacement. The initial velocity is given, time and acceleration are given. Great. Good job, guys. Okay. So now we will have displacement is equal to v initial time plus 1/2 acceleration time squared. Good. Now you notice here that I have on like those vector quantities are with a vector sign. However, since we have all the motion happening in one direction, you can ignore it. It's fine. So in which direction? On the direction that the plane is accelerating. So even if you write a formula like this, plus 1/2 at squared without the vector sign, still will be fine. Now let's substitute what they are giving us. So this will be equals to 0. Anything that is multiplied by 0 will be equal to 0. 1/2 times 3.20 times 32.8 squared. And now, since everything, all the units are, or every quantity is at the proper unit, meters per second and squared and seconds, then we can find that displacement is, please give me a number, guys. The calculator gives us 1,721.344 meters. However, I said that we have to record it into the correct sig-dig number. So the correct sig-dig number is 3, okay? Because we have 3 for acceleration, 3 for time. So the lowest number of sig-digs is 3. Therefore, the displacement, the final answer for the displacement will be 1.72 times 10 to the power of 123 meters. Now, very often you will see something like record your answer. Thank you, Andre. Record your answer into the form A dot BC times 10 to the power of D meters. And this is a numerical response answer. Now, then right below that, you will have 4 boxes. That means that on the first box, you will record what A is. On the second one, you will record what B is. On the third one, you will record what C is. And on the fourth one, you will record what D is. So a numerical response that will end up like this example here will have as the correct answer 1, 7, 2, and 3. Okay, so when you see an expression a dot bc times 10 to the power of d, sometimes you will see a negative d. That means that you have to put those digits a, b, c, and d in those 4 boxes. Do you remember what I said when we were talking about significant digits and all that stuff at the very, I think, first class that we had together, that I said that I believe that each and every one of you here is that smart to record 4 digits into 4 boxes. This is one of the examples of that I was talking about. So you cannot record more than 4 digits here because you have only 4 blocks to fill up. Questions? So let's take a look at this question here. A car starts from rest and accelerates uniformly over a time of 5.21 seconds for a distance of 110 meters. Well, let's start by sorting what is given and what they are asking for, because they're asking for the acceleration here. So what is given starts from rest. That means that what is 0, initial or final velocity? So it is initial. So V initial is equal to 0. And then 5.21 seconds, it's kind of given. You know that. 5.21 seconds. And it travels a distance of 110 meters. What is acceleration? So they are asking for acceleration. And let's go back to the same slide where we had all the kinematics equation. What is the kinematics equation that we will use? 1, 2, 3, 4, 5, or 6? It is 2 because we have the initial time displacement and we're looking for acceleration. So the equation that we will use will be v initial t plus 1 over 2 a t squared. Since the v initial is equal to 0, the whole term is equal to 0 because everything that is multiplied by 0, it gives you 0. So now, if we are going with the substituting everything and finding what they are looking for. So this will be 110 is equal to 1 over 2 times acceleration times 5.21 squared. So multiply both sides by 2 to get rid of the 2 that we have here. So 220 is equal to a 5.21 squared. Divide both sides by 5.21 to the power of 2, so that those 2 are canceled to the power of 2. And then acceleration, please give me a number, please. It is 8.104 meters per second squared, and so on. However, we have to record it into 3 significant digits because the lowest number of significant digits that are given is 3. So the acceleration will be 8.10 meters per second squared. If this was a numerical, good. If this was a numerical response question, then you will see express this to the correct significant digit. This is usually the expression that they use, and record them as a dot bc, and record them into the appropriate boxes, what you should expect is 4 boxes again, always is 4, guys. And then you will go A on this column, the decimal point on this column, B at this, and C at this. So the correct answer will be 8.10. Okay, so let's read this now or see this. If the Upton Chuck is riding a giant drop at Great America, if Upton free fall for 2.60 seconds, what will be its final velocity and how far will he fall? So when we see the free fall, what does that mean? Good. So the free fall, it means that the acceleration is 9.81 meters per second squared going down. We are assuming that this is happening near the surface of the Earth. So then, what we are saying here, well, the final velocity is not equal to 0, Andre, because we are looking for the final velocity. And when we are dropping, we will talk about this. So time is 2.60 seconds. And then it's riding. So it's a free fall. And then the assumption that we will do here is that the object, whatever is the object, is dropping. Okay, yes, initial velocity is equal to 0. Doesn't matter. Initial velocity, yes, Dylan, is equal to 0 because it is dropping. So we are assuming, imagine this, we are assuming that we have an object at a certain height. You are at a balcony of a high-rise building and you are dropping the object. Dropping it means that initial velocity is equal to 0. And you are looking for final velocity. So now here may be like, oh, but the object is stopping when it is reaching the ground. Yes, but we are looking for the slight whatever, 1 billionth of the seconds right before it hits the ground. Right before it hits the ground. This is what we are looking for. Okay, and now what we are looking for is final velocity and then what is the displacement. Now everything is happening in one direction, so and it's going down, even if you don't write the vector sign for the acceleration, you still will be fine because everything is going in one direction. So what is the formula that we will use now initially? So let's find this. Let's call this A and this B. In order to find the final velocity, what is the formula that we will use? Answers on the chat. Great. So we will use the acceleration. The acceleration formula will be V final minus V initial over time. And as I said, since everything is going in one direction, then we don't worry about adding the vector sign. Initial velocity is equal to 0, so then final velocity will be acceleration times time, or will be 9.81 times 2.60. Everything is at the proper unit, so then in your calculator 9.81 times 2.60 is equal to, the calculator gives you 25.506 meters per second. However, the only given on this question is 2.60 seconds, which is into 3 sig digs. So the final answer has to be on 3 sig digs. So the final answer for final velocity will be 25.5 meters per second going down. Okay, so this is for A. Now let's take a look and figure out what is B. What is the displacement? So again, let's refer to what is given. We know acceleration, we know time, we know initial velocity. What is the displacement? What is the formula that we will use for the displacement? 1, 2, 3, or 4, or 5, or 6? Will be number 2, because this is what is given, and this is what relates what is given with what they are asking for. So displacement will be v initial t plus 1/2 a t squared. And again, since everything is one direction, then we don't worry too much to write the vector sign. So initial velocity is equal to 0, then we will have 1/2 9.81 times 2.60 to the power of 2. The displacement will be 9.81 times 2.60 to the power of 2. What the calculator gives you is 33.1578 meters. However, we have to record it into 3 sig digs, so the correct answer, the way that you will record it, should be displacement is equal to 33.2 meters going down. Well, a race car accelerates uniformly from 18.5 meters per second to 46.1 meters per second in this many seconds. Determine the acceleration of the car. So this is very similar to what we did in the previous one. So I will leave you for 1 minute or so, then I will come back with an answer. Okay, so this is what you should have for this particular question. We went over on the previous lesson how to solve those type of questions. So initial final time given, and they're asking for acceleration. The formula that we'll use is the acceleration formula. And then what the calculator gives you is 11.17408 and so on. I have to record it to the appropriate number of sig digs, which in this case is 3. All the quantities that are given are 3 sig digs. So the final answer should be 11.2 meters per second squared. Questions? Do you have this answer on your notebook? Let's take a look at the other one. A feather is dropped on the moon from a height of 1.40 meters. The acceleration due to gravity on the surface of the moon is 1.67 meters per second squared. Determine the time for the feather to fall to the surface of the moon. So there are several assumptions that we are doing here. First of all, is that we are at the surface of the moon with an acceleration 1.67 meters per second squared due to gravity. Second is that we are assuming that there is no air in the moon. Therefore, the feather is falling down without the experiencing of the force of friction, which again we will talk it later on. Anyway, so we are assuming here that it's vacuum and the drop of the feather is not affected by any of the friction that feather may experience here in Earth, let's say. So displacement is 1.40 meters. And again, everything is happening down, so we don't have to state the direction of any of the vector quantities. The acceleration due to gravity on moon will be 1.67 meters per second squared, and we are looking for time. But there is one more quantity that is hidden here on the question that we can write it down as a given. So the word dropped means that the initial velocity is equal to 0. And what we are looking for is time. So what is the formula that we will use? And I will go back to the first slide that we have here. What is the formula that we will use to determine the time? Is first, second, third, what is it? Displacement is equal to the initial time plus 1/2 acceleration time squared. Or 1.40, this is equal to 0 since it is dropped, is equal to 1/2 times 1.67 times time squared. Multiply by 2 both sides, then you will have 2.80 is equal to 1.67 times squared. Divide both sides by 1.67, then you will have time squared is equal to 2.8 divided by 1.67 in your calculator, and you will have 1.676646 and whatever. Square root both sides, and then you will have the answer. Square root both sides. You will have time as what the calculator is giving you, 4.853 and so on seconds. So how do you record it? You take a look at how many sig digs, what is the lowest number of sig digs that you have on the as a given in your problem, and it is 3, so you have to record it into 3 sig digs. So the final answer will be time is equal to 1.29 seconds. And if this was a numerical response and you have to record it into those famous 4 boxes, then you will have 1, 2, 3, 4, 1.29. Question. Let's take a look at this example here. When we have an acceleration, well, it's accelerated to a speed of 444 meters per second in this many seconds. And what is the acceleration that it, and what is the distance that it is traveling? So we have that the object are used to test if a rocket powered sled is accelerated to a speed of this. So where is it starting, this rocket powered sled? Is it starting from rest, or it has a certain velocity? What do you understand from the question here? I want to see the answers on the chat. Is it starting from rest or from a certain point? Or in other words, what is the initial velocity and what is the final velocity? Good. Is accelerating from 0 to 444. Good. So the initial is equal to 0. The final is 444 meters per second. And the time is 1.83 seconds. What they are looking for is acceleration as A, and b is distance. Okay, what is the formula that we will use for the first one? For the first one, what is the formula that we will use on the chart? Acceleration formula. Good. Acceleration formula is v final minus v initial over time. So acceleration will be 444 minus 0 is not 444 still, 1 over 1.83. Since everything is the proper unit, we don't have to worry about what is to write the units to make sure that this is what is happening. So the what the calculator gives you is 442.6229 and some others meters per second squared. But you have to record it into 3 sig-digs. So the final answer will be acceleration is equal to 243 meters per second squared. Why 43? We will stop here at this digit, but since the following digit is greater than 5, then we round it up. Good. Questions? Now that we have to calculate the displacement, what is the formula that we will use? Let's take a look at the first slide here, and then let's use a different formula from 1 and 2, or 3 and 4. 2 and 3, sorry, 2 and 3. So, yes, 5 is a good one. Even 6 is a good one. Okay, 5 is a good one. You can use 5 as soon as you have initial, final, and time. Great. So let's go back to the question. And another thing, another suggestion that I will give you is to use as much as possible what the problem is giving you. Why am I saying this? Because if you are making a mistake on calculating acceleration on this case, and you are using that number to calculate the displacement, then you are making 2 mistakes. If this was a written response, then I will mark it correct because you are carrying the error forward. This is how is it known, carrying the error carries forward. But if this is a numerical response question, then you are making 2 questions wrong. So always have the tendency to use what is given on the problem as much as possible. So the formula that we will use on this case will be displacement is equal to V final plus V initial over 2 times time. And since V initial is equal to 0, this will be 444 divided by 2 times 1.83. So 444 divided by 2 is 222 times 1.83 is equal to 406.26 meters. The final answer should be recorded into 3 significant digits. So the final answer will be 406 meters. We do not change the last digit here because the following digit is less than 5. Question, we have this question. A bike accelerates uniformly from rest to a speed of 7.10 at a distance of s. Initial velocity is equal to 0. Final velocity is 7.10 meters per second. Distance or displacement is 35.4 meters. What is the acceleration? The formula that we will use will be the last one that you have on that box. which is V final squared is equal to V initial squared plus 2AD. So V final is 7.10 squared. This is equal to 0. 2 times A times 35.4. Divide both sides by 2 times 35.4. So those are canceled. 2 times 35.4. Then acceleration will be whatever is 7.10 squared divided by 2 times 35.4, and this will be 0.71200 and some more digits that the calculator is giving you, but we have to record it into 3 significant digits. So this will be acceleration 0.712 meters per second squared. If you want, you can write it into scientific notation form, 7.12 times 10 to the power of -1 meters per second squared, but there is no need. Okay, so now we have the last example here. Okay, the acceleration is 3.3 meters per second squared, and it takes off. The speed for this is 65 meters per second. Assuming that minimum acceleration, what is the maximum or the minimum allowed length of the runway? So if the plane is starting to move into a runway, then the initial velocity is equal to 0. Okay, final velocity is equal to 665, not 6.5 meters per second. And then the acceleration is 3. Well, should be 3.0. 3.0 meters per second squared. And we are looking for displacement. And again, on this case, what we will do is we'll use the last formula, V final squared is equal to V initial squared plus 2AD, because this relates everything. So we don't have to worry too much. V initial is equal to 0, so we'll have 65 squared is equal to 2 times 3.0 times D. Divide both sides by 3 times 2, which is 6. And then displacement will be 65 squared divided by 6 is 704.16 repeating meters. Since we are writing it in 2 significant digits, then the final answer will be displacement is 7.0 times 10 to the power of 2 meters. Okay, so the last thing here is the practice questions. So if you can work on those practice questions, not now because it is a bit too much and we are almost done today. So work on your own. Unfortunately, I don't have the answers here for those questions, but we can talk about those when we are starting the lesson tomorrow. So it's those questions that I would ask you to focus and practice today at home. And